Good morning, dear children. I'm going to take physics class for you. Last class we started the lesson motion. We are continuing with the same lesson. Okay. Last class we have discussed about two important physical quantities, that is distance and displacement, that are used to describe the overall motion of an object. Okay. Today we are going to start uniform and non-uniform motion. Uniform and non-uniform motion. Okay. Let us consider an example. A car starts from O and after 15 seconds it reaches A covering a distance of 20 meter. Okay, from the origin. Then the next 15 seconds it reaches B covering a distance of 40 meter from the origin. And next 15 seconds it reaches C covering a distance of 60 meter from the origin. Okay, and here for every 15 seconds the car covers a distance of 20 meter. For every 15 seconds the car covers a distance of 20 meter. That is, here the car covers equal distances in equal intervals of time. Okay, the car covers equal distances in equal intervals of time. Such a motion is called uniform motion. Okay, that is, in uniform motion, an object covers equal distances in equal intervals of time. In uniform motion, object covers equal distances in equal intervals of time. Okay, the rotation of earth and movement of hands of watch can be considered as uniform motion. Rotation of earth, movement of hands of watch can be considered as uniform motion. So, an object is said to be in uniform motion if it covers equal distances in equal intervals of time. An object is said to be in uniform motion, it covers equal distances in equal intervals of time. Okay, next consider another example. Okay, in which a car is moving on a busy road, it reaches A after covering a distance of 20 meter from the origin in 15 seconds. Okay, and next 15 seconds it reaches B, which is 60 meter from the origin, and next 15 seconds it reaches C, which is at a distance of 70 meter from the origin. Okay, here the car which is moving on a busy road, and it starts its journey from O and reaches A, which is at a distance of 20 meter from the origin. To cover the distance it takes 15 seconds. The next it reaches B, which is at a distance of 60 meter from the origin. To cover this distance it takes 15 seconds. And next 15 seconds it reaches C, which is at a distance of 70 meter from the origin. Okay, here in each case it covers unequal distances in equal intervals of time. Unequal distances in equal intervals of time. Unequal distances in equal intervals of time. Such a motion is called non-uniform motion. So, in non-uniform motion, object covers unequal distances in equal intervals of time. Okay. So, an object is said to be in non-uniform motion if it covers unequal distances in equal intervals of time. An object is said to be in non-uniform motion if it covers unequal distances in equal intervals of time. Okay, another example, suppose if a car moving on a crowded road or on a hilly area, it cannot cover equal distances in equal intervals of time. That thing can be considered as non-uniform motion. Also, the motion of a train starting from a railway station and stopping at the next station can also be considered as non-uniform motion. Motion of a train starting from a railway station and stopping at the next station can consider as non-uniform motion. Okay, that is about uniform and non-uniform motion. An object is said to be in uniform motion if it covers equal distances in equal intervals of time. Okay, an object is said to be in non-uniform motion if it covers unequal distances in equal intervals of time. Next, about measuring rate of motion. Measuring rate of motion. Okay, we know some objects move fast and some other object moves very slow. Okay, here we can consider an example. Consider three athletes A, B and C. Okay, running a 1,000-meter race. To reach the finishing point, A takes 5 minutes, then B takes 3 minutes and C takes 4 minutes. Okay, so we can say B is first and C is second and A takes the position of third. Okay, as the time taken by the B is least. Okay, how we can say B, the athlete B is the fastest, she takes less time to cover a particular distance. Among the three athletes, B takes less time to cover 1,000-meter race. So we can consider B as the fastest. Okay. So we can say the rate at which the objects move can be different. The rate at which the objects move can be different. Also, different objects can move at the same rate also. Okay, the different objects can move at the same rate also. So, the rate of motion actually depends upon, here we are considering the distance traveled, also the time. So, the rate of motion mainly depends on the distance and the time. The rate of motion mainly depends on the distance traveled and time taken to cover the distance. So we can say for measuring the rate of motion, we need distance as well as time. Okay, for measuring the rate of motion, we need distance and time. For that, to describe the rate of motion, we are using a physical quantity that is called speed. Okay, that is called speed. For measuring the rate of motion, we are using a physical quantity that is called speed. Okay. Then what is mean by speed actually? Here the rate of, we already said the rate of motion that depends upon, or we can define the rate of motion in terms of distance and time. So we can represent the speed in terms of distance and time. The speed of an object means the distance travelled per unit time. Distance travelled per unit time. Speed of an object means the distance travelled per unit time. Okay, the speed means distance travelled per unit time. So we can represent speed equal to distance divided by time. Okay, speed equal to distance divided by time. Speed equal to distance divided by time. Suppose if an object covers s distance in time t, then the speed v can be represented as s by t. This is the equation for speed. Okay, if an object covers s distance during the time t, then the speed v can be represented as s by t. Okay, speed v is equal to s by t, where s stands for the distance travelled and t stands for the time taken to cover that distance. Okay, then what is the SI unit of speed? You know the unit of distance, that it is meter. Okay, divided by what is the unit of time? It is second. It is represented as S. Okay, this can be written as meter second raised to minus 1 or meter per second. This is the SI unit of speed. Meter second raised to minus 1 or meter per second is the SI unit of speed. Okay. And here the speed is a scalar quantity. Speed is a scalar quantity. That is, to define speed we need only its magnitude. Last class we have discussed about the scalar and vector quantities. Okay, scalar quantities are those quantities having magnitude alone. No need of specify the direction. Here when we consider speed, we need only its magnitude. No need to take its direction. So speed can be considered as a scalar quantity. The speed can be considered as a scalar quantity. Okay. Then other units of speed. We can use centimeter per second and also kilometer per hour. These are the other units of speed. We can represent speed in centimeter per second and kilometer per second. Kilometer per hour. Okay, these are the other units of speed, centimeter per second and kilometer per hour. Okay, that is about speed. Speed of an object means distance travelled per unit time. Then what is the equation for speed? Speed V is equal to S by T. Its unit is meter second raised to minus 1 or meter per second. And speed is a scalar quantity. Okay. And next, the speed of an object need not be a constant. Okay, the speed of an object need not be a constant. When we consider uniform motion, we know that in uniform motion, when an object is in uniform motion, it does not cover equal distances in equal intervals of time. Okay, in that case, the speed is not a constant. Okay, in uniform motion, the speed remains constant because object covers equal distances in equal intervals of time. But in non-uniform motion, the object does not cover equal distances in equal intervals of time. Okay, in this case, the speed is not a constant. So, we have to consider the average speed. Average speed. So, in the case of non-uniform motion, we have to calculate average speed. Okay, in the case of non-uniform motion, we have to consider average speed. Why we are considering average speed? Because the speed is not a constant in the case of non-uniform motion. Then how we obtain average speed? It can be obtained by dividing the total distance travelled by total time taken. Average speed can be obtained by dividing total distance travelled by the total time taken. Okay, average speed can be obtained by dividing the total distance travelled by total time taken. So, we can write average speed is equal to total distance travelled divided by total time. Okay, average speed equal to total distance travelled by total time taken. Average speed can be obtained by dividing the total distance travelled by the total time taken. So, we can represent average speed equal to total distance divided by total time taken. Okay, that is about speed. Okay, next we have two devices, that is odometer and speedometer. Okay, you know the use of odometer. Actually, it is used to find the distance travelled by vehicles, to measure the distance travelled by vehicles. The odometer is a device which is used to measure the distance travelled by vehicles. Okay, the speedometer, which is used to measure the speed of vehicles. Okay, speedometer is a device which is used to measure the speed of vehicles. In speedometer, the speed can be represented in kilometer per hour. The speed is represented in kilometer per hour in the case of speedometer. So we have two devices, odometer and a speedometer. Odometer is used to measure the distance traveled by vehicles, and speedometer is used to measure the speed of vehicles. Okay, in speedometer the speed is represented in kilometer per hour. Okay, that is about the speed and average speed. Next about speed with the direction. Speed with the direction. Okay. The speed, the rate of motion of an object can be more comprehensive if we specify the direction of motion along with the speed. Okay, that is along with the speed of an object. When we consider the direction of motion, the rate of motion becomes more complicated. In that case, we are using a physical quantity to represent both the aspects. That is both magnitude and direction. We are using a physical quantity that is called velocity. Okay, that is called velocity. Okay, but velocity means along with the speed we have to specify its direction. Okay, so velocity is the speed of an object moving in a particular direction. Moving in a particular direction. What is velocity? Speed of an object moving in a definite direction is called velocity. Velocity of an object means the speed of an object, moving object in a particular direction. Okay, speed of an object moving in a definite or particular direction is called velocity. Then how we can calculate velocity? For that we are describing velocity in terms of displacement. Okay, we can also express velocity in terms of displacement. Okay, that is velocity is equal to displacement divided by time. Okay, velocity is the ratio of displacement and time. Okay, velocity is the displacement of an object in unit time. That is called velocity in terms of displacement. Okay, we already said the speed of an object moving in a definite direction gives velocity, and velocity can be calculated by taking the ratio of displacement and time. So velocity is equal to displacement divided by time. Okay, you know the equation for speed. Speed is equal to distance divided by time. Okay, speed is equal to distance divided by time. Okay, along with the distance, we considering the direction, it becomes displacement. So velocity can be written as displacement divided by time. Okay, that is about velocity. Velocity is equal to displacement divided by time. Then how the velocity of an object may change? How we can change the velocity of an object? Okay, it can be changed by either change the speed of an object, or we can change the direction, or both. Okay. Okay, that is the velocity of an object can be changed by either its speed or direction, or both. Both the speed and direction changes, velocity also changes. Okay, if the speed of an object changes, velocity changes. If the direction of motion changes, velocity also changes. If both the speed and direction of motion changes, velocity also gets changed. Okay. Okay. So, the velocity mainly depends upon the speed of moving object and its direction of motion. Okay. And if the velocity of an object is changing at a uniform rate, we can calculate the average velocity. If the velocity of an object is changing at a uniform rate, in that case, we can calculate the average velocity. We can calculate the average velocity. Okay. Then how we can calculate the average velocity? It can be calculated as taking the arithmetic mean of initial velocity and final velocity. So average velocity is equal to initial velocity plus final velocity divided by 2. This is the way for calculating the average velocity. Okay, average velocity is given by the arithmetic mean of initial velocity and final velocity. That is, average velocity is equal to initial velocity plus final velocity divided by 2. Initial velocity plus final velocity divided by 2. Okay, if the velocity of an object is changing at a uniform rate, we have to calculate the average velocity. Average velocity is given by the arithmetic mean of initial velocity and final velocity for a given period of time. Okay, the average velocity can be represented as initial velocity plus final velocity divided by 2. Then mathematically, we can represent this average velocity as follows. Suppose if the initial velocity is represented as u, initial velocity is represented as u and the final velocity is represented as v and the average velocity is represented as v average, then this equation becomes, instead of average velocity we can write v average. Then initial velocity is represented as u, then final velocity is represented as v divided by 2. This is the mathematical expression for average velocity. V average is equal to u plus v by 2. V average is equal to u plus v by 2. Okay, average velocity is equal to u plus v divided by 2. Okay. Then what is the unit of velocity? It has the same unit as that of speed, that is meter per second or meter second raised to minus 1 is the unit of velocity. What is the unit of velocity? Meter per second or meter second raised to minus 1 represent the unit of velocity. And here we already mentioned speed with the direction is called velocity. So we are considering the direction of motion also. So velocity is a vector quantity. Velocity is a vector quantity. Velocity is a vector quantity. So we have discussed the two physical quantities, speed and velocity. Speed and velocity. Speed means distance traveled per unit time and velocity means speed of an object moving in a particular direction. So we can compare or we can distinguish these two physical quantities, that is speed and velocity. Speed and velocity. The first is, speed is distance traveled by an object in unit time. Okay. Distance traveled by an object in unit time is called speed. Then velocity, speed of an object moving in a definite direction, that is called velocity. Okay. Then speed is a scalar quantity and velocity is a vector quantity. Velocity is a vector quantity and speed is a scalar quantity. Here speed is always positive. Here we are not considering the direction. Speed is always positive. And the velocity is both positive and negative. Because we are considering the direction of motion, velocity is both positive and negative. Then speed equal to distance divided by time and velocity is equal to displacement divided by time. Okay, these are the difference between speed and velocity. Okay, what is speed? Distance traveled per unit time, that is called speed. Then velocity, speed of an object moving in a particular direction gives velocity. then speed is a scalar quantity, then velocity is a vector quantity, speed is always positive, velocity is both positive and negative, then speed is equal to distance by time, and velocity is equal to displacement divided by time. Okay, velocity is equal to displacement divided by time. Okay, that is about the difference between speed and velocity. The next about rate of change of velocity. Rate of change of velocity. Okay. Suppose if an object is in uniform motion along a straight line, velocity is a constant. Okay. Suppose if an object in a uniform motion which is also moving along a straight line, its velocity remains constant. Okay. But when we consider non-uniform motion, velocity varies with the time. Okay. In the case of uniform motion, velocity remains constant. But when we consider non-uniform motion, velocity is not constant. Okay, it varies with the time. That is, it has different values at different instants, at different points in its path. Okay, so it has different values at different instants, at different points in its path. So the change in velocity is not zero. Okay, in the case of uniform motion, the velocity remains constant, so its change in velocity is zero. But in the case of non-uniform motion, the velocity is not a constant. So the change in velocity is not zero. Then how we can represent the change in velocity of an object? Okay, how we can represent the change in velocity of an object? For that we are using another one physical quantity which is called acceleration. Okay, for representing the change in velocity of an object, we are using a physical quantity that is called acceleration. Okay, then how we can measure acceleration? It is a measure of change in velocity of an object per unit time. So acceleration is equal to change in velocity divided by time. Okay, acceleration is a measure of the change in velocity of an object per unit time. Okay, acceleration is a measure of change in velocity of an object per unit time. That is, acceleration is equal to change in velocity divided by time. Acceleration is equal to change in velocity divided by time. Okay. Next we are considering if the velocity of an object changes from an initial value u. That is, initially that object moves with a velocity u. Then after a time t, its velocity changes to v. That represents the final value. Okay, if the velocity of an object changes from an initial value u to a final value v during the time t, then the acceleration can be represented as a is equal to, acceleration is represented by a. Okay, here we have to find the change in velocity. Actually, change in velocity means a final velocity minus initial velocity. Change in velocity, final velocity minus initial velocity. Here the final velocity is v. So we can write v minus initial velocity is u. U divided by time t. This is the mathematical expression for acceleration. That is, acceleration a is equal to v minus u by t. Acceleration a is equal to v minus u by t. Okay, that is what is acceleration. Acceleration is a measure of the change in velocity of an object per unit time. Acceleration is a measure of the change in velocity of an object per unit time. So acceleration can be written as change in velocity divided by time. Change in velocity means final velocity minus initial velocity. Okay. Next we are considering the velocity of an object changes from an initial value u to the final value v during the time t, then acceleration a is equal to v minus u by t. Okay, that is, instead of change in velocity, we have to write final velocity minus initial velocity. Here the final velocity is v and initial velocity is u. So we can write v minus u by t. Acceleration a is equal to v minus u by t. Okay, then what is the unit of acceleration? What is the unit of acceleration? We can find acceleration is the ratio of change in velocity by time. You already know the unit of velocity, that is meter second raised to minus 1 divided by time, second. Okay, when this second goes up, it becomes s raised to second raised to minus 1. Here meter second raised to minus 1, it becomes minus 2. Okay, so this is the unit of acceleration. So the unit of acceleration is meter second raised to minus 2 or meter per second square. Okay, the unit of acceleration is meter second raised to minus 2 or meter per second square. Okay, meter second raised to minus 2 or meter per second square is the unit of acceleration. Also, here acceleration is a vector quantity because we are taking the ratio of velocity by time. Velocity is a vector quantity. So acceleration is a vector quantity. For describing acceleration, we need the direction also. So acceleration can be represented as a vector quantity. Okay, that is about acceleration. Next, the acceleration is positive or negative. Acceleration is either positive or negative. Suppose if the acceleration is in the direction of velocity, it can be taken as positive. Okay. If the acceleration is in the direction of velocity, it can be taken as positive. Suppose when we drop an object downward, its velocity increases. So here the acceleration and velocity are in the same direction. Okay. In that case, the acceleration is considered as positive. Okay. Here we know the equation for acceleration. A is equal to v minus u by t. Okay. Here v is going on increasing. So we can write v greater than u. When v greater than u, A becomes positive. Okay. We have two types of acceleration, positive acceleration and negative acceleration. If the velocity of an object and the acceleration is in the same direction, acceleration is said to be positive. Here the velocity, that is the final velocity, increases. So we can write v greater than this u. Okay, u the initial velocity. In that case, A becomes positive. Okay. And in the case of negative acceleration, if the acceleration is opposite to the direction of velocity, we can acceleration as negative. Suppose if we throw an object upward, the velocity that is going on decreasing, that is in the upward direction, but the acceleration that is in the downward direction. Here the acceleration is due to Earth's gravitational force. That we will discuss in the next chapter. Detail we will study about the Earth's gravitation. The lesson gravitation. Okay. But here the acceleration is in the downward direction and the velocity that is in the upward direction. So in this case, acceleration is taken as negative. The acceleration is not in the same direction as that of velocity. Okay, here the velocity is going on decreasing. When we throw an object upward, the velocity is decreasing. So the v is less than u. Okay, v is taken as less than u. In that case, if v is less than u, then A becomes negative. Okay, v is less than u, so A becomes negative. Okay, that is about the positive and negative acceleration. If the acceleration is in the same direction of velocity, it is called positive acceleration. Okay, in the case of positive acceleration is v greater than u. V is greater than u, so the acceleration A becomes positive. In the case of negative acceleration, the acceleration is in opposite direction of velocity. In that case, v is less than u, so a becomes negative. Okay, the negative acceleration is otherwise called deceleration. The negative acceleration is otherwise called deceleration or retardation. The negative acceleration is otherwise called deceleration or retardation. Okay. The negative acceleration is otherwise called deceleration or retardation. Okay. That is about acceleration. So, we are going to wind up today's class. After summarizing what all today we have studied about, we studied the physical quantities speed. Speed means distance traveled per unit time is called speed. Then about velocity, speed of an object moving in a particular direction, that is called velocity. Next we studied acceleration. Okay, acceleration means change in velocity of an object in unit time is called acceleration. Then what are the equations of speed? Speed equal to distance by time. Then velocity is equal to displacement divided by time. Then acceleration is equal to change in velocity by time. Okay, change in velocity by time. Also we studied average speed. Average speed is the ratio of total distance traveled by total time taken. Also we studied average velocity. Average velocity is the arithmetic mean of initial velocity and final velocity. Okay, average velocity is the arithmetic mean of initial velocity and final velocity. Okay, that is the end of today's class. Thank you, children.